These are the hardest, these are the hardest kind of problems where I give you the f prime and I want you to graph f of x, and sorry, I forgot to say it here. F of x is continuous. Its domain is all reals. Sorry, that's very messy. F of x is, let's say, defined on all reals. So you can't make holes or vertical asymptotes or anything. Okay, so let's look at and see what we've got. I see that I've got critical numbers, right? X equal -1 and x equals 0 and x equals -3. I'm sorry, that's a +3, silly me. +3. Okay, so let's think about this. X equal -1 is a critical number where the derivative equals 0, right? And this is a critical number where the derivative equals 0. Oops, 0, 0. Okay, so I think we can use the first derivative test, right? So before looking at x equal -1, before -1 it's negative, after -1 it's positive. So since y prime changes from negative to positive, therefore f of -1 is a local minimum. Okay, got a little bit of a graph. So let me make some room up here. So it's always nice to like start with little baby steps because all these graphs are little baby steps. Okay, so f of -1 is a local min. So -1, we'll just make it a local min. Slope is 0, right? So it's the bottom of a parabola. So it's decreasing before -1 and it's increasing after -1. Okay, so what's happening at 0? At 0, the derivative doesn't exist, right? Oh, okay. So that means f prime doesn't exist. I still can use the first derivative test. So let's see, y prime changes, because it does change, right? From positive to negative, right? So that means f of 0 must be a local max. Whoops, local max. I don't have enough room. Therefore, f of 0, okay, is a local max. Okay, so let's think about this. It's where the derivative doesn't exist. So it's either got to be a cusp, a corner, a vertical tangent. I'm thinking like cuspy thing, right? Going up and then coming down. Okay, so I'm just going to put that cuspy thing there. Then at +3, I don't know why I've got that negative there. At +3, do you see the derivative doesn't change sign? So there's no max or min. Okay, so that means at 3, it's going down, slope 0, down. Okay, so that's a beginning of the graph, right? We got the ups and downs, and we've got what's happening at those critical numbers. Okay, so let me get rid of this stuff so I can keep going on the graph. So now, didn't mean to do that, but let's see. Okay, I got the graph here. I'll draw it again. I didn't think it would go away. Okay, so get rid of this. Okay, so my f prime look like this. Went up, -1, and then it went like this and this at 3. Okay, so when the f prime is increasing, which means it's going up, there's going up, right? F prime is increasing. That means f double prime is bigger than 0, right? It's positive. And so that means that f is concave up. So the graph is concave up when the thing is going up. Okay, where else is it increasing? Oh, look at that. It's increasing here to here, right? So it's increasing here and here. So it's concave up between -infinity and -1. I'm sorry, -infinity to 0, right? -infinity to 0, and then again from 0 to 3. Okay, so let's look at what that means on the graph. Concave up. Oh, and then it stops at 0 just because it's a cuspy thing. Nothing's happening in a cuspy thing, right? And then it's concave up. Okay, so what's happening over here? This is where f prime is decreasing, so that means f double prime is less than 0. And so that means f is concave down. So it's cupped down after 3. So 3 to infinity, cupped down. So it looks like that. So just get rid of that little guy there, right there. And there's your graph.